I'd like to welcome all of you to this Q&A session. Thank you for submitting your notices of intent and for submitting all your questions in advance. We've been busy working to get answers to them and to share some more information with you about this year's challenge. My name is Shelley Spears. I'm the Director of Education and Outreach at the National Institute of Aerospace. And it is just an honor and privilege to work with the wonderful sponsors at NASA on this particular challenge. It's one of our favorites, nothing better than hands-on technology demonstrations. So a couple of housekeeping things. I just want to let you know that this session is being recorded. And so the audio and a written transcript will both be available for you all to refer to at a later date. And also the FAQs, all the questions that have been posted and are being answered will also be on the FAQ page. If you have additional questions that come in, you'll have other opportunities to submit those, and then we will be providing answers on that FAQ page at another, as they filter in. And we'll go over a little bit more about that as well. I do want to just ask you just a reminder to mute your mics while we're on this particular call today. That'll just help with the process. And if you have any kind of a question as we go through all of the questions and answers today, there is a chat feature that's available. And go ahead and just drop those in there, and we'll be monitoring that, and we'll try to get back to you and get any of those additional questions that you might have answered. I'm going to go ahead and introduce the program staff. This is the team that work with me at the National Institute of Aerospace. There's some pictures there, I see. So Stacy Dees is the portfolio manager for our higher ed competitions and the program manager for this Moon to Mars Ice and Prospecting Challenge. And she is supported by Tori O'Leary, who's a project coordinator, and also Jen Eberly, who's a project coordinator. So those are the three folks that you'll be primarily interacting with in the NIA side. And then we have a wonderful panel of experts and judges that you will hopefully really get a chance. Well, I know when we have our face-to-face, hopefully we'll be able to do that here next year. Meet these wonderful folks. So just thought I'd go through, you can see the list here of folks that are the judges. They're just, they're an amazing group of people. So we've got Dean with Honeybee Robotics, Ben, he's with NASA Langley. We've got Steve Hoffman, who's with Aerospace Corporation, based out of NASA JSC. Sharon Jeffries, and she's at NASA Langley. Chris Jones, he's also our lead sponsor for this. He's at NASA Langley. Kevin Kempton at NASA Langley, Bob Moses at NASA Langley, Keith Nicewarner, who's with SpaceX, Jerry Sanders, who's at JSC, and then we have Chris Sackney, who's with Honeybee Robotics. So we work really closely with this team to help design and develop a very rigorous but yet doable challenge for you all as we work hard to identify methods and approaches to harvesting resources from the surface of Moon and Mars. So with that, I'm going to go ahead and turn this over now to Stacy and ask her to pick up the baton and lead the rest of the meeting for us. And she'll go through it, kind of exactly what's going to happen. But the questions have been submitted. They're probably likely going to be organized in by topics. If there were multiple questions, well, there you go. There's the agenda. And so, Stacey, why don't you go ahead and take it from here? And I'm going to go ahead and turn my camera off and listen to the rest of it, and look forward to the call today. Thank you all so much. Stacey?
Well, thanks for kicking us off, Shelley. As you can see, we've got the agenda all laid out for you here. We are going to spend a few minutes hearing from Dr. Christopher Jones as he just shares a little bit of context about the challenge, why kind of NASA is doing it, and what the judges will be looking for. And then I'm going to talk to you again for just a few minutes about some just general programmatic items that you need to know about and be aware of, maybe some things that have changed since we initially launched the competition a few months ago, and just making sure that everybody's on the same page with all the same information. Then we'll go through those questions and allow any additional questions, time permitting, and wrap up and get you guys out of here before 5 o'clock. So with that, I am now going to turn the baton over to Dr. Jones to talk to you all a little bit more about NASA's perspective for the challenge.
Thanks, Stacy. So welcome, everybody. We're really glad to have you here. Again, this is the 5th year we have done this, and going to be the 3rd year now where we focused on both the role of prospecting on the moon and acquiring water ice on Mars. The reason why we're doing this, of course, is we've got big plans here at NASA, first for returning to the moon in 2024 and going on to sustain our presence there, and then going on to send humans to Mars after that. And we know that in order to explore the moon well, we're going to need to be able to understand what's there better than what we were able to do in the days of Apollo, and better than what we've been able to do to date with what we've flown there. And certainly there is the possibility that the levels and quantities of ice we might acquire there could someday be a significant contributor to how we explore the solar system. And I think to maybe even a greater degree, there's a ton of value that can be had from being able to acquire water ice on Mars and leverage that for the production of propellant and consumables, and just as a general feedstock into a variety of processes that could really support what we're looking to do. So in all of this, what we're looking for from you are ideas for how to go about doing these things. And what we want is for the teams that are proposing here to think about what it would take to do effective prospecting on the moon and what it would take to do effective acquisition of water and ice on Mars. And in doing that, to come up with a technology demonstration that, if everything bears out nicely, will allow us to bring folks in to demonstrate that at NASA Langley next summer. So to that end, we're looking to hear some great ideas and submissions from all of you, and be able to learn from that and inform the plans NASA has going forward. Stace, back to you.
All right, thanks for that, Chris. There's just 2 things really that I wanted to point out to everybody and make sure that everybody was aware of. The first is that this year, for the first year, the challenge is being incredibly strict on not allowing collaborations with foreign universities. And I know in the past we have allowed some collaborations with foreign universities. And so for those of you that are returning and have participated before and maybe have had a student or 2 from a different university outside of the United States, we just wanted to let you know that that's something that cannot happen this year. NASA is getting stricter and stricter on that as some different things are changing, and especially when there's competitions like this where there might be intellectual property or things that could be used for NASA missions in the future, they're just being a little bit extra strict and a little extra careful on who that information is shared with. So want to make sure that everybody is aware of that change this year, and that we really are being strict. And if you do have any collaborations with foreign universities that you may have started already, you cannot have them for the proposal, or your proposal will be considered ineligible. The next thing is that since we launched the program, NASA has provided us with an official intellectual property statement for the challenge, so that everybody knows exactly who the property, the concepts of all those sort of things belong to. And the whole statement is here. It's on the website. We'll be providing it to you in email form as well. But just the basis of it is that since NASA is funding some of this work at the university level, they will allow all of the property, the intellectual property that your university has come up with, to remain with the university, remain with the participants, but that the government is able to use it anytime that they want to. So they retain the rights to use it royalty free. And I just want to make sure that everybody is aware of that, and that your universities are aware of that as well. So that's a little bit new and different from the past. It's kind of the same way we've been operating for years, but now the statement is out there officially for you to be able to utilize and reference. And so with that, we're going to go ahead and kick into the next section of the question and answer session here today and get to the nitty-gritty of what you guys are looking for. So I'm going to read the question, and we'll have Dr. Chris Jones will be responding. We have a few other judges that are on the line as well, and I'd like to encourage any of our other judges, if you want to augment some of these answers or provide a little bit of clarification, you're welcome to jump in at any point in time as well. All right, so Chris, starting with our technical questions, For the power supplies, is the idea to join them on a bus and use only one AC plug, or to use an independent plug for each supply?
So there needs to be just a single power cable that's connected to the volt or amp meters to measure the electrical power being consumed by the test hardware. After this point, you can use multiple plugs that are connected to the individual pieces of your hardware or your computers, but the power meter we use must be able to measure all the power being used by your test hardware, and that power management and distribution in the test hardware is a design responsibility for the team.
All right, question 2. If a sleeve is implemented to reinforce drilled holes in the overburden, is it required for it to be extracted after completing a day of the competition?
So because subsequent days each require you to start with a new hole, generally the answer is going to be yes. The sleeve should be removed at the end of a competition day. However, you could theoretically still leave the old sleeve in the simulated regolith, but would then need to use a new sleeve for the new hole the next day, and the mass of all of those sleeves is going to count to your mass budget.
All right, moving to the next slide in question 3. Regarding the regeneration requirement of the filter, if our filtration system can function for 12 hours without needing to regenerate, should our assembly still include a regeneration or backwash mechanism? Would it instead be sufficient to explain how we could hypothetically do regeneration?
So you do need to explain how your system would be regenerated in actual operations on Mars and taking into account the environmental effects of being on Mars. But if you don't need to regenerate your filter during the competition, then you do not need to demonstrate it. But again, make sure you explain how that would work in a real system.
All right. Is there a specific location or terrain that we should base designs on, as obviously Mars has multiple terrains?
No, we still have not decided on a particular landing site for our mission, so we would encourage you to review recent literature and research on Mars and on potential destinations to determine the best location or terrain that could be targeted for harvesting ice with your system, and to provide a good rationale for your selection.
Great, thanks. Question 5. What are some successful tactics that we can use to test the effectiveness of our drilling and water extraction?
Okay, I think if there's one lesson we've learned as the judges to try and bring to the teams over the years, it's we really encourage you to integrate your subsystems and ultimately your full system as early as possible, and leave plenty of time for testing and revision, both in terms of time and in resources, because we've seen plenty of times where teams don't discover something doesn't quite work the way they intended it to until they bring that whole system together, and sometimes that doesn't happen until the opening day of the competition. We also encourage you, similarly, as you're doing your testing, to push to the limits or the boundaries of what you're up against here. Try not to just do your testing on just a very idealized situation, but understand what you're going to do if things start to go wrong. Really, it's planning that testing strategy early on. We would even recommend that you have a team member whose focus is leading the test environment and making that environment as realistic as possible, and that you start designing and building that in parallel with your actual drilling and water collection system. Now, ultimately, what we want teams to do is come up with their own creative solutions for all of the aspects of the competition, including testing, because what we're looking to do here is, as much fun as it is to bring you in and see the systems here, we're looking to get real ideas that we can bring into what we're doing at NASA and that our industry partners can also learn from. So we want you to be creative, but we do encourage you to review the technical papers from previous winning teams, which can be found on the archives webpage, as well as the lessons learned documents on the resource web pages, which will get you some of the lessons that even previous students have remarked upon having gone through this in the past.
And I will say that for those of you who have looked at the lessons learned document, you will have seen that time and time again, that's the one thing that the teams say over and over and over again is our tip number 1 on this question. Absolutely do your integration and testing early. If you're thinking about or asking about when you should be testing, you're already too late, is some of the advice from previous teams. All right, let's move on to 6. Where can we find data to test our prediction models besides running our own tests?
All right, so this is going to be very dependent on the specific system you're proposing and what you're attempting to model there. So your best bet is to run your own tests to support your models. You may glean something useful again from looking over the technical papers of the previous teams and the lessons learned. But ultimately, I think this is going to kind of be just something you're going to have to deal with as you're doing your own testing and development.
All right. Can we expect a theoretical rod well that's created on day 1 of the competition to be in the same state as day 2 of the competition?
So at the end of day 1, all of your hardware has to be withdrawn from the actual testing environment and turned off. We'll cover the test bed with an insulating space blanket for the overnight period, and of course the cooler itself is fairly well insulated, but there's not any other provisions besides the dry ice that's already in there and the thermal inertia from the ice that's you're drilling through that's actually going to maintain the environmental conditions in there. So you should expect the test bed conditions to be similar to those at the end of day 1, but there's certainly no guarantee that they will be identical at the beginning of day 2. So don't expect that a rod well that you sank on day 1 is going to be just immediately available to drill a new hole and tap into in day 2. In fact, we don't allow teams to use the same hole going into the overburden on day 2 that they used in day 1 for any run that counts for scoring. If you do have a rod well and you want to assess its condition, you can use a robotically deployed camera on your system as part of your integrated system to inspect the hole, and that may inform your strategy going into the next day.
All right, question number 8. Can ambient air be blown into the core to improve the efficiency of melting?
All right, so as a general reminder here, the real focus we're on here are concepts that we could actually implement on the moon and on Mars. So because of that, using ambient air would kind of require that the airflow mass and the temperature you're blowing in be equivalent to something that's Mars atmosphere analogous if it's a non-sealed drill hole, or you would need to seal the drill hole with the corresponding inflow, outflow valving, and air pump in order to do that. And in both cases, whatever mass and power you need in order to do that will count towards your system specifications. And your design report would then need to elaborate on why this would actually work on Mars. So it's a long way of saying that just using the ambient air because it's 95 degrees in Hampton in June, you can't do that. If you're going to try and do something along those lines, you need to make it resemble a real concept that you could actually use on Mars.
All right, so similar question for number 9. Can a heat exchanger be used to take advantage of ambient air conditions outside the icebox?
Okay, so a heat exchanger as a thermal management device is allowed, but teams again are going to have to explain how a real heat exchanger for a Mars water extraction system would equate to the one that's being used under Earth atmospheric conditions. So again, you're going to have to make that analogy case successfully to the steering committee that what you're attempting to do here would work on Mars and how the demonstration you're doing is analogous to that. And again, the mass, the power, the volume of what you're using to do that is going to count towards your limits.
All right, thanks, Chris. And before we get into question number 10, just to let everybody know to kind of give you a sense of what to expect. We have 40 questions, so there's another 30 that we need to get through that we received in advance. But as we're going through this, if additional questions come up that you would like for us to address at the end of the call, we'd like you to just go ahead and plop those questions right into the chat. And then we can make sure to get to them first come, first served kind of a thing that happened at the end of the call. So moving on to question number 10. What material properties are required for the digital core? For example, specific hardness, impact strength, compressive strength. Do we need to determine what each material is in the overburden area or just the material properties?
Okay, so we've got an example here of the digital core form on the slide, and I think, Stacy, this is also available in a larger form on the competition website. So all we're looking for on the form here is just some very basic properties. How many layers do you think there are in the test bed? What's the general ordering of those layers in terms of softest to hardest, and an estimate of their depth in centimeters? If your system is able to produce more specific information, estimating the strengths of the layers, we would love to see it, and there is certainly the possibility that we would give a special award for somebody providing a particularly detailed and accurate digital core. If you've got the ability to go above and beyond and fit it in with everything else you're doing, we'd love to see it.
All right, question 11. Are there any safety requirements regarding microwave heating? Assuming that all necessary safety concerns are addressed, would it be acceptable to use microwave radiation to melt the ice?
Okay, we're not going to automatically rule out the use of microwave radiation for melting the ice. However, any plans that are proposing use of microwave radiation will be subject to NASA and Air Force Safety Office approval. Just as a note, we are right next door to Langley's Air Force Base, especially in the hangar we're in, and so there's additional safety precautions that we have to take into account from both the NASA perspective and also the military's perspective, safety and electromagnetic interference. If you are selected as a finalist and you're proposing microwave radiation, then that's going to be subject to multiple safety reviews throughout the year. We're going to want to do an initial review of what you're proposing to do at the proposal stage, do a follow-up review at the midpoint project review, including a detailed diagram and photographs of the setup you're using, and a description of any leak testing that you've performed and the instrumentation you used to do that. And then there will be a final radiation leakage test on site at the competition. And frankly, during any of these safety reviews, the NASA Safety Office has the ability to refuse the approval to use this at Langley. So again, we're not categorically ruling it out, but keep in mind that there are a lot of hurdles to overcome from a safety point of view and a review process in order to incorporate that.
And with that being said, we have had a team successfully use and go through the approval process to be able to use that during the competition. So there is a little bit of precedent, but there are some hoops to jump through to do so. All right, question 12. For a water recirculation system, we might need some priming water in the system. This water would be the initial source of heat before any ice is melted and would continue to recirculate through the heat exchanger and Rodwell until collection time.
Okay, so we were a little bit unsure at first what we were actually being asked here. Our interpretation was that this was asking about bringing in a pre-measured amount of water to prime the system, and then we would be making sure to subtract that from the total. So yes, you can have a pre-tank of water included as part of your competition hardware to allow for priming. However, we do need to be able to weigh that water and have a judge review that weight before the start of the competition so that we then can subtract that out and not count it towards the amount of water that gets extracted. And the team needs to discuss very clearly how that tank would be incorporated in an actual mission design as part of their final concept.
All right, question 13. Are multiple tethers or cords allowed between the system and the operators? Are multiple operators or computers allowed? And if more than one operator is allowed, are the two operators allowed to communicate with each other?
Okay, so yes, multiple tethers or cords are allowed between the system and the operators, and you're allowed to have multiple operators and computers in use to do that. The two operators certainly can communicate with each other during hands-on operation, but not during hands-off operations unless we've got two operators, say, who are not physically observing the system and are relaying, down and in looking at the system state, but might, be sitting together at a table at a remove from the system. They could still be communicating to each other during hands-off operation.
A lot of responses in one answer. All right. What kind of control should the user have from the computer?
That is up to each individual team, so do what works best for you.
Question 15. Is the maximum thickness of a layer 25 centimeters? We'd found this information in the 2019 Q&A.
Okay, so the whole overburden will be comprised of multiple layers, and that entire setup will be between 0.4 and 0.5 meters. Each of these layers is going to be, measurable here. We're not going to try and make them, sub-millimeter thickness or anything. Frankly, we can't do that with what we're setting up for the test beds here. So we're not going to give specific minimums or maximum thicknesses there. But, thinking reasonably here, there will be more than one layer. There will be less than, say, 10 layers. Frankly, significantly less, I would say, than 10 layers. And the overall setup will be between 0.4 and 0.5 meters.
Question 16. What is the threading of the 3-inch carriage bolts that can be used for mounting?
Okay, so we have a standard threading here, and they are actually 5-inch through bolts with a 1/2-inch diameter, where there will be 3 inches of the bolt that are exposed above the deck from the washer and the nut up. These don't come standard with the test frames because some teams prefer to just mount their rigs directly to the wooden frame. If you would like the 3-inch carriage bolts to be used to mount to the frame, then let us know so that we can sort of include that in our planning if you're selected.
Question 17. Regarding the concrete used in the competition, what is the type of aggregate? What is the type of cement? Do you have a specified concrete mixture? This information will really help us create our own mixture and simulate the conditions of the competition.
So it's definitely a good goal to be trying to simulate the competition conditions. I think that will help support your testing. But again, we don't want to provide any of the specifics about the overburden, because part of the point of this digital core exercise is for you to have to drill through a relatively unknown substance, or a substance that falls somewhere in some general bounds we've given you, and be able to operate given that uncertainty. So we're not going to provide any further detail on it.
All right, question 18 is one that everybody needs to pay close attention to. Are there any chemical or material restrictions for electrical or chemical-based filtration system?
All right, and I'm just going to go ahead and read this one verbatim here to make sure we get everything covered. So, explosives, combustibles, open flames, and cutting fluids are strictly prohibited. All hazardous materials, chemicals, and pressurized systems, for example, pressure vessels or pressurized liquids, are subject to review and approval by Langley's Safety. Approval from the Safety Office could take up to 6 weeks. Teams will need to submit a material data sheet for anything that may be hazardous with their proposal, and please list any chemicals you plan to use in your proposal. Also, while it's not restricted per se, we don't recommend using a coagulant to melt the ice.
All right, question 19. Does the system need to be both manually controllable and automated?
So at no point does the system have to be autonomous, although that would certainly be very cool to see. We've got a full description of the hands-on and hands-off operation in the document that we have linked here. We do, however, ask that the water extraction system be capable of operating autonomously or via remote crew-controlled operations during the competition. Either system operation is acceptable, as either could be used on the Moon or Mars, and autonomous control or remote crew-controlled operations are considered hands-off operations. So to give you a little bit more about the definitions there, and then you can see the document for more details or potentially submit a follow-up question. Autonomous control is that the system doesn't require any human intervention after it starts. You press your go button and away we go. No further operation is needed from the crew. Remote crew control, which is what we've generally seen a lot of teams do in the past, allows for the use of a computer that's distinct from, but able to communicate with, the water extraction and prospecting system. So you connect it by a cable or a Bluetooth connection to operate that water extraction system, to have things like control of the drill, speed, or positioning, if you're using a drill. Those remote crew-controlled operations indicate that the crew will be near their test station. In this case, we ask that you have that operating within 5 feet and within line of sight, so that you can figure out when problems occur and address those problems remotely. Systems shouldn't be built that they will require human intervention. They should be built such that they would work on their own while being controlled remotely, and then you have that ability to use the interfaces you've set up to operate that.
And Chris, part of the requirement of being 5 feet within line of sight, the way that the test stations will be set up, each test station will have 2 tables near it that are all within 5 feet. And so that's just the way that everybody will be set up in general at the competition. All right. Question number 20. What are the dimensions of the collection container, and is it located at the base of the system or at ground level?
Okay, so the collection container, our external accumulation tank, is 15 inches tall, and it's, well, here I'm going to go ahead and mix units, so let me back that up and say it's 38 centimeters tall with a 31 centimeter diameter. It's rated for 22 quarts. Teams can choose to place it on the ground, as you see here in this picture, or on one of your tables that Stacy just alluded to that's next to the test station.
And on this document that we will post on the FAQs with the transcript, there is a link there to the exact collection container that we purchased. So if teams want to buy the exact one, We'll direct you right to where we purchased it from. Moving on to question 21. Since our peristaltic tubes are rated in hours, is longevity a scoring criterion? And if so, what is the expected longevity of our system?
Okay, so longevity itself is not a scoring criterion. We encourage you to take a look at the final scoring matrix, and I'm not going to reiterate all the evaluation criteria that are here on the slide. That's available there, but I do want to note that at a minimum, your system does need to be able to last through the 3-day competition at Langley, but beyond that, there's no specific length of time that it has to last. Now, when you get to the path to flight section of your technical paper, and when you address this in other areas, you should talk about the modifications you'd have to make to the system to allow it to survive for potentially years of operation on the moon or especially on Mars.
And I will make a note here that in the past, several teams have indicated that some of their materials got burnt out a lot quicker than they expected them to. So, you know, it doesn't sound like 3 days is a long time, but when they're operating continuously, sometimes it is. So make sure when you're doing that testing, you really put your materials through the rigor. All right, question 22. Is power going to be a limitation?
Yep, that's one of the points of the competition here. So we've got details for that on the webpage. The notes here I'll call out amongst everything here is you do need to be able to operate on a limited supply. 120 volts of AC current that's coming off a GFCI protected power, and that you will need to include a 9 amp fast blow fuse into your circuitry so that we can keep you limited under the power requirements that we want to limit you to. For the rest of this, I think we'll leave it to you to review, but we do want to note that you can't augment your system's power supply with batteries or solar power. And this is applying to the water extraction and the prospecting system. You can use a separate power outlet, for example, for the computer that you're using to control your system, but then you cannot wire your way to use the control system to then power the water extraction system.
Question 23. Do we only have to submit the digital core form to the judges at the end of the competition?
So you can submit it at any point during the competition up to the end, but once you've turned it in, that will be considered your team's final submission and you can't make any additional changes.
And with that digital core, do we have to show a picture or graph of the layers drilled through, or are we able to use the rig data in any way that we'd like?
So we've got the standard form here, which is what you'll turn in and what you'll be evaluated on. However else you want to arrive at what you do to populate this is up to your own team.
All right, 25. We have moved now into more miscellaneous questions, some of which are technical. My team and I are currently conducting technical research. We've been using the public domain of the NASA technical report server and have not found it particularly useful. Is there anywhere else for us to find technical reports from NASA?
So, I mean, I will say that, you know, how we actually go about harvesting water from extraterrestrial subsurface ice is, all things considered, a relatively new area of study. We're still trying to figure it out, and that's why we're here with this competition. We do have some resources in the recommended reading list on the competition resource page. I think that's a good place to start. I think for many of you, you may also be able to access your university's technical libraries and the resources they have to point you to other papers that have been published on the subject. Above and beyond what's on the NASA Technical Reports server.
And I would also add to that, perhaps doing a search on the AIAA papers that have been submitted to the AIAA conferences. All right, question 26. What is the needed longevity of the rover or ice mining system?
So, as we said, at a minimum, it does need to last through the 3-day competition at Langley. Beyond that, it doesn't need to last any particular amount longer. But again, in your path to flight, when you're describing the system as it would actually be implemented, you need to address the modifications that would enable it to survive for multiple years on especially the Martian environment, but also in the lunar environment.
So what are some challenges that have been overlooked when adapting the design to function in Martian environments?
Okay, so a couple of things here to consider bringing up, because we do sometimes see these get overlooked, is The potential for certain impurities, especially those that would be particularly hazardous to human health, like perchlorate salts, that could be in the Martian water or ice or get incorporated into that, and how filtration would deal with that. We haven't actually talked a lot in the previous year's challenges about especially the natural impurities that you may encounter, because we probably won't find a nice, shiny, clean block of ice the way that you'll have for the test bed. With what we've looked at before, we've limited the filtration to keeping the sediments out of hoses and valves and pumps. So again, we would really encourage you to talk about how you might deal with those natural impurities if this were a real Mars operation.
All right, moving on to question 28. These are now more of the programmatic questions, and I'm actually going to ask Tori to read the question and I'll answer them.
Hi, Stacey, can you hear me?
Yes, ma'am.
Great. So question 28 is there a unique aspect of the design you would like to see someone incorporate this year?
So the purpose of this competition isn't necessarily to examine unique designs, but to have teams consider the same problem and determine their own path to success. So designs that focus more on operating under actual mission environments versus those that might work best under Earth ambient air or pressure conditions are the ones that are going to be preferred by the judges.
29. What are some common design flaws teams in the past have run into?
So the judges kind of went back and forth on this. I think ultimately as a group decided that we'd like to prefer not to really answer this question in too much detail, but there are a couple of common flaws that they can emphasize that just very generically are failure to test an integrated system in a test environment that closely resembles the competition environment, and then failure to allow enough time to change and retest design features that fail to work as expected in integrated testing. So it goes back to those tips that were provided earlier. Integrate and test early and often. And then again, we have provided those resources for you under the resources webpage for lessons learned and the technical papers from the winning teams on the archives page. We really encourage you just to dive into those and pull out some of those nuggets of information about things that were challenging for the teams and how they may have overcome them, and that will help you a lot. We don't want to give you all the answers straight out, but you could do the research that we've provided for you.
All right, 30. How much programming needs to be reflected within the project proposal?
So teams really need to be able to summarize how their system works, but you don't need to include your code or any detailed algorithms or anything of that nature in the proposal.
31. Should the proposal be written considering the on-site competition or its actual use on Mars or the Moon?
The judges want to see that the rig you're proposing can be successful at the Earth-based on-site competition, but that you've put a lot of thought into the design for use on either the Moon or Mars. Using the path to flight section to highlight how your concept could be feasible for use on the Moon or Mars is going to be critically important here.
All right, 32. What aspects of space deployability haven't been addressed in past experiments?
We're really not looking for teams to explore new ideas for deployability, except in how they enable your system to support prospecting on the Moon and acquiring water on Mars.
33. Can you please clarify what you mean by teams can manually reposition the drill between subsequent hands-off stages?
So that means that if you need to move your drill around, you can actually touch it and physically manipulate it to where you need to move it to. It doesn't have to happen robotically. And so just going back to some of the language that's provided in the rules, it states if you have to touch the system, even to move it, those actions will be considered hands-on operations. It should be noted that once the systems are attached to the top of the test beds, they need to stay attached. However, teams may manually move or reposition their actual drills between subsequent hands-off operations without penalty. If a team plans to use manual repositioning, careful consideration should be taken in the path to flight section of their project plan proposal to articulate how this would translate into operations off Earth.
Number 34. Our team will likely seek help from more faculty members as the year progresses. Can additional academic advisors be added to the project later?
Absolutely, and that actually extends to additional student team members as well. We just really want to make sure that anybody and everybody who contributed to your project is acknowledged in the proposal. And if you are selected as a finalist, then later into the technical paper. Oftentimes we'll see new students or advisors added after even the proposal has been submitted, and that's okay too.
35. We have a few members who are graduating in December, but would like to stay in the team and help with the project. Is that permissible? Would these graduates be allowed to represent the team at the on-site competition?
So from our perspective, yes, that's absolutely okay and acceptable. However, we have found in the past sometimes that can be a little bit tricky with using university funds to support your travel or registration to the forum. So if that's the case for any of our finalist teams, we just would encourage you to reach out to your universities early on and find out how or if they are able to support those students even after they're no longer enrolled at the university.
36. If we encounter new advisors before the proposal submission, do we need to add them to the initial list of advisors? If so, how do we do that?
You don't need to do anything or add them to any initial list so far. Instead, we just simply ask that you include them on your proposal. That's all you need to do.
37. How many teams signed up in 2019 versus how many were selected?
We get this question every year, and unfortunately, this is not information that is shared publicly, but we can tell you that the pool was competitive and 10 teams were ultimately selected.
All right, 38. We have a prototype from last year's Minds team which did not make it into the competition due to COVID. Would we still count this as a returning team even though they did not originally compete?
Yes, that team would technically be a returning team because they were accepted into the 2020 competition.
39. This is a long one. Is there any transportation for prototypes that NASA will provide or recommend?
Okay, so first off, NASA does not provide transportation for them, and we actually put the responsibility for transporting the prototypes to the teams. And the teams and the systems have to get to NASA on their own. So we found that in the past, that means that most teams will opt to rent like a large truck or a trailer, or if their university has one that they can borrow, they'll use that and actually go with the prototype itself, mostly because they don't like to see it out of their sight and they want to make sure it's being handled properly. Once you get to NASA, there's flatbed dollies that teams can use to transport their system from their vehicle to the test bed inside of the hangar. And even though a lot of teams do choose to drive their prototypes with them, some have shipped it in the past. And when you read through the lessons learned, you'll actually see that some of the teams experience some issues with that, with vibration or with handlers not being extra careful. We've had some prototypes that were shipped that weren't packaged very well and ended up damaged, or at least a piece was damaged. And so then we've had other teams that have created their own crates. They packed it themselves, they made a custom design crate, and they shipped it with no problems. So if you do choose to ship it, make sure that you do it carefully, pack everything carefully, use lots of foam to especially protect your electronics so that they're not affected by the vibration. And the hotel that we use for our finalists, we actually will provide specific shipping instructions to the hotel if you choose to ship your prototype to the hotel, but then you'd be responsible for getting it from the hotel to NASA using a rental car or truck, what have you.
All right, number 40. If questions arise after this Q&A as our design efforts progress, will we have any point of contact or opportunity to clarify them before the project plan submission deadline? If questions arise after the project plan submission deadline, will there be any point of contact or opportunity to clarify them before the competition?
Absolutely. Throughout the rest of the competition after this Q&A session, any questions can be sent to this email address that's listed here. It's the rascal@nianet.org email address. And we will not only provide a written response to you, but we will also post that response on the FAQs page so that everybody has access to the information. We don't ever just respond to one team and they're the only team that has that information. We want to be fair and open and make sure that everybody is on an equal playing field. So we really do encourage you to look back at the FAQs frequently to see if any new questions and answers have been posted so that you have access to all the same information as all the other teams. I will say that the one caveat I would have to this is please do not send us questions 2 days before your proposal and expect an answer that is going to get back to you in time to be able to be incorporated into your proposal. Last year we had a number of questions all come in at the last minute, hours even sometimes before the proposal deadline. So make sure if you do have questions, you get them to us with enough time for us to get an appropriate response back to you.
All right.
And I think that may be it. Oh no, we have a few more. I thought it was only 40.
More.
I guess.
Okay, so number 41, will the containers that will be drilled into be kept at a certain temperature during the procedure?
So the containers are not monitored for exact temperature, but they really are truly well insulated. They have 5 inches of insulation built into the test bins around them. There's a significant amount of dry ice and styrofoam, and you have these big ice blocks. It keeps everything very, very cold. And as Chris mentioned earlier, we do use a space blanket and add it to the top of your container each evening. Historically speaking, the ice blocks that are inside the bins have remained frozen for an entire week, even in 90+ degree temperatures in Fahrenheit. And they've lasted the entire week without having any significant meltage of the ice or even meltage of the ice at all. So teams can assume that the atmospheric temperature is going to be about 25 to 30 degrees Celsius. And the overburden is going to have a gradient anywhere from 20 degrees Celsius at the surface to -10 degrees Celsius at the ice interface.
All right, number 42. How long in a day can you drill/pump?
So there will be a total of 12 hours of the actual competition where you can drill, pump, or extract water from the simulated planetary test bed. We have not determined the exact breakout yet. There's a lot of things that the schedule is dependent on that are outside of our control, and we don't know yet since there's a lot of closures and things going on with COVID. We do know it's probably going to be something like either 6 hours on one day and 6 hours on the following day, or it may be 4 hours on one day and 8 hours the next day, something like that. It wouldn't be too far off the mark from there, but you'll have 12 hours total.
All right, 43. What sort of interface capabilities will the integrated Windows 10 computer have?
And that question is outside of the scope of this competition, so we won't be providing an answer to that one.
And that's it.
All right, again, so here's just that reminder that any future questions that you have, you can send them to us at the rascal@nianet.org address, and we really will post them all to the FAQs and respond to your question personally as well. So with that, we'd like to open the floor up to any additional questions that you all may have. If you have any, feel free to drop them in the chat real quick, and we can try to address them right now before you get off.
All right, and we do have one question on here that I think has already been answered. What is the thread size of the carriage bolts?
Inches. 2 by 5.
So this is the answer that we provided. Do we have any additional questions?
If for those
In terms of more detail on what that threading is, we can, I think, Stacy, potentially check into that by checking with Keith.
Yeah, so we will, a lot of us, well, all of us actually right now aren't technically on site, and we're not able to go in and actually physically measure some of this stuff. So if you need the specific thread size there, we will find out from our facilities manager who is on site and post that in this transcript on the FAQs when we post it within the week.
All right. And if anybody has questions, please post them in the chat.
And while we're maybe waiting for somebody to write a question or two, Tori, let's go ahead and go to the next slide. I just want to make sure I get through some of these before we wrap up here today, if no other questions come through. All right, next slide for me. There you go. We will be posting a transcript of this question and answer session. We'll have a written transcript so that you can go through and, you know, search by keywords and that sort of thing. And we'll also post the audio if you'd like to go back and reference anything in the audio. That'll be on the FAQs page. Just give us about a week to get that up. And a reminder that your proposals are due on November 24th, right before midnight on the 24th. And we'll be letting you all know what your selection status is by December the 14th. And if we don't have any other questions, I think we can just say again, thank you all for your interest in this challenge. We cannot wait to see what you have proposed for us. And we really do encourage you to go through and read those lessons learned, read the technical papers that are there so that you're not reinventing the wheel, but that you can keep just building on the shoulders of the students and the teams that came before you. So best of luck to you all, and we look forward to those proposals January 24th. Take care, everyone.